I have worked for Arabs for 40 years in the Midlands, so I think I know Midland geology fairly well. Um, this talk was actually given to the Midland Geotechnical Society just before Christmas, but I say that I have adapted it to make it more geological with a few extra bits added on. So this isn't exactly the talk I gave for the MGS, but um, it is similar. So I shall then go on to my outlook, and this is the outline of the talk I'm going to give this evening. I'm going to say an introduction on geological context and background, brief history of research and nomenclature. I'm not going to say very much about that. There's some comments on mineralogy, which is actually quite an interesting and developing field, and then describe in more detail the occurrence of salt or halite in the Cheshire, Stafford and Needwood basins. Then I'm going to change tack and talk about the gypsum within the Mercia mudstone, and particularly the occurrence of what's known or what I have identified as a solution front. And finally, some conclusions with certainly some actions there for somebody. So really to kick off, the Mercia mudstone is a non-marine aeolian, fluvial and alluvial sediment deposited under arid desert conditions in the middle of the Pangaea supercontinent. It is predominantly a fine-grained mud rock, reflecting low energy conditions of transport and deposition across a broad platform with very little topography in front of the deeply eroded Variscan Mountains to the south. Deposition took place in temporary lakes and, going back there because let's go back to where I was. Much of the sediment input is actually from wind-blown dust, and then it is reworked by occasional influxes of water. What I like to try and do now is just get, there we go, that's better. I can see all my text now. Yeah, much of this dust comprises silt-sized aggregates of clay minerals. The Mercia mudstone is therefore essentially an aeolian deposit, and in the geological history, it's probably a fairly unusual deposit. Thicker deposits accumulated in the rifted basins established during Sherwood sandstone times, and in the centres of many of these depositional basins, you've got thick halite deposits accumulating from occasional seawater incursions. And sulfate deposits of gypsum and hydrite are also important, which form an economic resource in places. So a bit about the nomenclature, as probably most of you know that the Mercia mudstone used to be known as the Kuiper Marl, but the term became obsolete once it was realised in the 1960s that the UK Triassic section was not equivalent to the German Triassic sequence. Like the Sherwood sandstone, the detailed nomenclature of the Mercia mudstone has recently changed, forming publication of the formational framework for the Mercia mudstone group in 2008. Previously, a series of formation names have become established for the East Midland Shelf, but for some of the Midland basins, the Mercia mudstone group remained undivided. However, the 2008 publication established a sequence of formation names across all the depositional basins, using the names previously used for southwest England. And this introduces terms which some of you might be familiar with, some not. But you have, in descending order, the Blue Anchor Formation, the Branscombe Mudstone Formation, the Arden Sandstone Formation, the Sidmouth Mudstone Formation, and the Tarporley Siltstone Formation. And the halite formations have become members. So originally the Wilkinsley halite was a formation and has now become a member within the Sidmouth Mudstone Formation of the Cheshire Basin. So a brief look at the history of research. This is not a full bibliography, but as a Mercia mudstone is encountered across many parts of the UK, especially in the Midlands, its engineering properties have been widely studied. And the early work dated from the 1960s with the Road Research Laboratory on the mineralogy, from samples taken from road projects across the Midlands. And they subsequently became a PhD at Birmingham University on the mineralogy, structure and engineering properties of the Cork-and-Marl Mercia mudstone. And building on this PhD, the Syria then published a research programme at the University of Birmingham, and the following classic publications followed. This was one by Rick Chandler from 1969 on the effect of weathering on the shear strength properties. And this introduced the weathering scheme, which is still used today. And then in 1973, Chandler and Davies collaborated for further work on the engineering properties of the Mercia mudstone. Then moving forward, the next milestone is that in 1998, Syria held a seminar in Derby on the engineering properties of the Mercia mudstone group, to which I attended and participated and presented a paper for. And following from this, Syria updated their 1973 report, and in the Syria report C5730, and this very much is a seminal subject for the engineering properties of
Should
the
you have a
Mercia
video
mudstone.
on? Start the video. Look there.
Can you not see? I'm screen sharing.
I think we can see your screen, Adrian. I think people would like to see your face. Do you think you could turn your camera on?
Yes.
There we go.
Can people see me now?
Yeah, that's lovely. Thank you.
Okay, right. I shall carry on, but I say this is very much the sort of introductory section. But yeah, if people like to sort of see me in my glory, that's fine. Yeah, I was just saying the history of research at the Mercia mudstone really had quite a bit of work in the 60s, and then there was a gap. It was the seminar in 1998, and then there was a Syria publication in 2001, and finally the BGS, as part of their engineering geology of British rocks and soils, produced a research report on the mudstone, the Mercia mudstone group. So that is a brief review on history of research. It's not intended to be a full bibliography, but it just indicates that research into the Mercia mudstone has been a bit sporadic. Let's try and, sorry, I'm not quite sure why, but the screen share is. The next section I just wanted to talk about is the Mercia mudstone mineralogy. The Mercia mudstone is not homogeneous. Some beds are blocky with little structure. Other beds are laminated with clear signs of fluvial reworking. And these differences show up in the mineralogy from XRD work. The blocky lithology is dominated by the aeolian clay minerals, the silt-sized clay minerals which come in. There is minor gypsum and dolomite, and there is a modest clastic component. The laminated lithology is somewhat different. It has much greater gypsum and dolomite component, and rather more less minerals of clay type. And then a third lithology is noted in the strata above the Stafford halite member. This contains much more clastic material and is dolomite cemented. This strata would be more resistant to erosion and probably is responsible for the elevated topography south of Stone, the Peasley Bank Hill. And it's possible this strata might be equivalent to the Arden Sandstone Formation in the Stafford Basin. There is much more data out there now, to form a mineralogical database for the Mercia Mudstone to supersede significantly that from the 1960s. This subject would warrant a separate talk. The Mercia Mudstone sequence in many of the depositional basins contains evaporites of salt or halite. The evaporites generally occur in the middle and upper parts of the Sidmouth Mudstone Formation, but always in the same part of the sequence. Also, in some areas, e.g. the Cheshire, Stafford and Needle basins, the evaporites apparently replace the Arden Sandstone Formation, or there may be nonconformity, or the Arden Sandstone might actually still be present. Details of the evaporite strata are very variable. In parts of the Cheshire Basin with a mining history, the strata sequence is well known. Similarly, in the Stafford Basin, where there was a brine extraction into the 1960s, the strata sequence is very well known. However, in the Needle Basin and the Cheshire Basin south of Crewe, details are fragmentary. The evaporite strata are also important within the Worcester Basin at Droitwich, where the resultant brine streams were very important in Roman times. The evaporite deposits are rarely purely halite. There's usually a certain amount of interstitial mudstone. However, in the northern part of the Cheshire Basin, there are two horizons in the lower part of the Northwich halite member with little or no impurities. This is the top rock and the bottom bed. All the historical mining focused on these beds. The present Winsford mine has excavated the bottom bed beneath a very large area to the northeast of Middlewich. This section on the Cheshire Basin mainly considers what was found during the mining filling project at Northwich, and a brief reference is made to an area south of Crewe. A brief history of Northwich, that during pre-industrial times, brine in Northwich area was extracted from shallow wells or pits along the River Dane, where natural brine was out of close to the surface. A boring for coal encountered rock salt at relatively shallow depth to the northeast of Northwich in 1670. This discovery resulted in many small mines being sunk to the rock salt deposits in the Northwich area. However, the discovery of a lower bed of salt in 1779 resulted in a rapid phasing out of top bed mines and the beginning of an extensive phase of mining in the lower bed that lasted throughout the 19th century. The advent of steam engines in the early 19th century resulted in a rapid increase in brine pumping from where brine was present to that where natural brine was virtually exhausted by the middle of the 19th century. This led to the practice of bastard brine pumping, whereby brine was extracted from flooded top and bottom bed mines, leading to widespread surface instability. This was phased out in the 1930s. In 1875, the Winnington Works were established by Brunamond to the northwest of Northwich, and brine was extracted from a natural source there until 1926. The new Cheshire Salt Works to the northeast of Northwich continued to extract natural brine from a natural source until 2006. There was a perverse reluctance in the Northwich area to produce brine by dissolving mined halite, and the practice of producing crystalline salt by evaporating brine persisted into modern times. It was finally closed in 1986 and is now a museum. During the early 20th century, significant surface instability affected Northwich, as exampled here from 1905. Details of salt and halite beds in the Northwich area were obtained by a project to assess the stability of the remaining open mine workings beneath Northwich town centre and infill them. Arrett were involved in the infilling stage, which took place between 2005 and 2007. There was an opportunity to inspect some of the borehole core from the infilling boreholes. There were a few surprises. Brecciated strata was observed, as expected in the Mercia Mudstone, above the Northwich halite. However, this is a key observation. On close inspection, zones of undisturbed strata were noted in between the brecciated zones. This observation suggested that the brecciation was contemporaneous, i.e. of Triassic age, and not due to a more recent solution process forming a collapsed breccia on the mudstone salt interface, the classic wet rockhead. The granular marl or horse bean structure noted by the miners in the 19th century was also seen. The granular structure appeared to reflect the presence of hard gypsiferous nodules and are indicated to be contemporaneous, i.e. like the brecciation and not a residue of solution, at least within the study area. It was observed that the top of the Mercia mudstone just above the Northwich halite was softened, reflecting historic dissolution of the halite below. Just below the top of the Northwich halite, subhorizontal solution X discontinuities were noted, reflecting historical dissolution from brine pumping. One of the important features at Northwich is the occurrence of a glacial channel eroded into the top of the Northwich halite. The natural solution front and the presence of brine appear to relate to this feature, where fresh water in the glacial sands comes into contact with the salt deposits. So these tentative conclusions and observations were made in 2008 following the infilling work and the observations at that time. And this is noted that the extraction of brine regionally, but probably mainly from the Winnington works to northwestern Northwich, is indicated to have drawn fresh water from the Glacial Channel directly into the halite deposits, causing catastrophic surface settlements. Due to this, images of tilted and subsided buildings in Northwich town centre at the beginning of the 20th century were commonplace. It should be noted the problems in Northwich town centre were not primarily due to mining or bastard brine pumping, as often quoted in the literature. It is considered likely that the superimposition of the natural solution processes associated with the Glacial Channel onto the contemporaneous Triassic brecciation has caused confusion as to the origin of the so-called wet rockhead collapsed breccia, as defined by the Geological Survey, at least in the Northwich area. Details of the Anderton area. Northwich is on the edge of the Cheshire salt deposits, and the lensing out of the salt deposits to the northwest was reported by Stanier in 1933. The details suggest that the salt mudstone interface is probably not related to the current erosion cycle. Brine occurred in fissures and not on the salt mudstone contact. Brine springs in Northwich on River Dane were the original source of salt in pre-industrial times. These have long since disappeared due to years of past mining and brine pumping in the area. It is surprising, therefore, to find a present-day brine spring in the Anderton area, northwest of Norwich town centre. And this was visited when we were doing the infilling works in the mid-noughties. Few comments about the Cheshire Basin south of Crewe. Historically, there were brine springs along the valley of the River Weaver, especially at Nantwich, but none further east. However, there was a history of instability affecting the Church of Wybenbury. In 1832, under excavation was used to stabilise the tower, the same technique recently used to stabilise the Leaning Tower of Pisa. Further work was required in 1989, and a slight lean has been retained. Boreholes sunk in 1971 indicated 107 metres of drift overlying salt beds, i.e. a drift channel have been eroded into the halite deposits like at Northwich. The adjacent Wimberbury Moss has a floating raft of peat 5 meters thick overlying 30 meters water as a result of subsidence. Recent deep boreholes have been sunk south of Crewe to investigate the interface between the glacier deposits and the Wilkersley halite member. There were a few surprises. None of the boreholes to date have encountered, as expected, an interface between the Wilkersley halite member and the glacial deposits. Instead, they have entered intact Mercia mudstone strata beneath a very thick and variable glacial drift cover. Some bores I did encounter halite belonging to the Wilkersley halite member below 20 to 40 meters of intact Mercia mudstone, as shown in the example below. Significantly, some brecciated fabric was noted in the Mercia mudstone above the halite. The Winsford mine is excavated in the lower part of the Northwich halite member and extends beneath a large area. It is noted that the Northwich halite lenses out as it approaches the major King Street fault to the east. However, no brine is reported on this interface, suggesting that the lensing out dates from the geological past, perhaps like at Anderton. The halite is worked by a mechanical excavator to form galleries 8 to 9 meters high, 20 meters wide and 20 meters square with supporting pillars, and you can just about see an operative standing next to the excavating machine there to give some idea of the size of these underground cavities. I now want to move on to the Stafford Basin. That Stolt halite, accompanied by brine within the Mercia mudstone strata of the Stafford Basin, the Stafford halite member, was discovered by accident in 1889 by boreholes just north of Stafford town centre, which was sunk for water supply. Brine extraction commenced in 1893, and this rapidly eclipsed the Shirley-Witch and western areas to the east of Stafford, where production had been in decline due to the limited supply of brine. Production soon reached 80,000 tonnes per year and was sustained at this level for the early part of the 20th century. During this period, no adverse effects from the brine extraction were noted. However, following a short period of increased production in 1939, surface settlement to the south of production boreholes started to be noticed, affecting northern Stafford. The area affected expanded across much of northern Stafford during the 1950s and 60s and was terminated by a successful court action by the Lotus Shoe Factory in 1969. The shoe factory had suffered considerable subsidence damage. Boreholes sunk for British Salt in 1970 and for housing development on the northeast of Stafford in 1967 provide a reasonable amount of information on the Stafford halite member beneath Stafford. The halite beds are present in the sequence of strata about 15 to 40 meters thick, with the top of the halite occurring at a depth of about 60 to 100 meters. Above the halite beds, the geologists logging the boreholes frequently noted brecciated strata. Across the northern part of the Stafford Basin, halite deposits are indicated to be present at depth in that crop. To investigate these deposits, a series of deep boreholes have been sunk. Two of these boreholes encountered the top of the depth at 105 meters, which is a bit deeper than expected. The top of the halite was intact, with no indication of solution disturbance. Brecciated strata was encountered in the overlying strata as expected. It had a very similar character to the brecciated strata in the Needle Basin and Cheshire Basin. This suggests that the brecciated strata should be considered to be part of the Stafford halite member. The zone of brecciated strata was thicker than expected, about 80 meters, suggesting that overall the Stafford halite member in the Stafford Basin, which is a brecciated strata plus a halite, could be well over 100 meters thick. The top of the brecciated strata was poorly defined, but you also saw coarsely crystalline gypsum as seen in the Needwood Basin and the Cheshire Basins. Where did brine come from? One of the mysteries of the Stafford Basin is the source of the brine that supplied the salt industry, particularly prior to 1939, when that short period of increased production fractured the strata and allowed groundwater direct access to the salt beds. Prior to 1939, pumping had gone on for many years without any obvious effects. Might I offer some personal tentative suggestions? In other areas, it is noted that brine is often associated with glacial channels eroded into the top of the salt deposits. There is a candidate for this in the Stafford area, the Doxey Marshes. And I'm not the first person to suggest this, because Staffordshire Wildlife in their notes on Doxey Marshes makes the following observation. There are 4 main flashes on the marshes formed by subsidence during the salt extraction in Stafford's history. And this is illustrated. A deep glacial channel is indicated to underlie this area and was encountered in boreholes for the M6 Cresswell Viaduct. Brine was also noted in a historical borehole near Stafford Station on the access of this channel. The area of historic brine production is just east of this glacial channel and may have tapped brine within it. None of the present-day areas of standing water within the Doxey Marshes were present on the first edition Ordnance Survey map. And this is the interesting bit. A recent subsidence is noted on the edge of the Doxey Marshes, and you can see that on this figure. There's a car park area just in this area here. And that's what it looked like. That was a recent subsidence noted in the car park access room adjacent to Doxey Marshes. That is no longer there today because that area has been subsequently restored. So that's all I want to say about the Stafford Basin. And I wish to move on to the Needwood Basin. And this is a geological map showing the southwest part of the Needwood Basin, showing the approximate crop of the Powdery Gypsum and the approximate crop of the Stafford halite member. And I'd just like to point out several salient features which I'll be referring to in the next section. There is a Baggots Farm borehole. There is the Chartley Moss, the Chartley borehole. There's a gypsum mine. There was a Shirley Witch borehole and the Essex Bridge borehole. The detailed halite member within the Needwood Basin Mercia Mudstone are provided by 3 deep boreholes, the Shirley Witch, Chartley and Baggots Park borehole. The Chartley and Baggots Park borehole show the Sulfurous zone of mudstone and minor halite about 65 meters thick. The Shirley Witch borehole was logged by a geologist in 1970 who made some useful observations. No in situ halite was observed. However, he noted zones of Pencantemporine breccia within a 65 meter thick sequence of mudstone strata. Also, it is noted that the approximate horizon of Powdery Gypsum occurs about 60 meters above the Stafford halite member. It wasn't present in the Chartley borehole for reasons which I'll explain in a minute. In the Baggots Park borehole, there's quite a broad zone where gypsum and hydrite was present, suggesting that the gypsum halite perhaps had split a bit in this area. There are the brine springs associated with the halite in the Needwood Basin. Historically, a strong brine spring was located on the southwest side of the River Trent watercourse to the southwest of Weston. It supplied an important salt industry. This feature was reported by Dr. Plott in 1686, Natural History of Staffordshire. The 1775 Yates map of Staffordshire shows a pumping engine on the site of this spring. However, during the early 19th century, it is reported that brine from the source was diluted by freshwater incursion. This source was presumably degraded further by continued extraction of brine from boreholes to northeast at Shirleywych and Weston during the 19th century. There is no indication that the brine spring exists today. And on this plan, I just show the location or conjectured location of the St. Erasmus well, which I shall talk about in a minute. Other diffuse historical seepages along the River Trent Valley bottom produce local salt marsh ecosystems. There's also a medieval healing spring, the Well of St. Erasmus. This spring was still visible in the early 19th century because Pitt in 1817 acknowledged it to be clear and good might still be beneficial. It was described as having no significant smell and taste, but was slightly yellowish in colour. The current location of this interesting feature is surprisingly unknown today. It may be adjacent to Inglestowe Hall, and this is what I have dug out of the internet. Inglestowe, St. Erasmus Well. Here is another well famous for the cure of the king's evil, known as St. Erasmus Well of sulfurous quality. In the reign of Henry VII, a chapel was built near the spring. The Chetwynd manuscript in the William Salt Library in Stafford records that an aged man, formerly clerk there, told Walter Chetwynd that the adjoining wells were much frequented by lame and diseased people, many whereof found there a cure for their infirmity, inasmuch that at the dissolution thereof the walls were hung about with crutches, the relics of those who had benefited nearby. Nor was the advantage small to the priest. The oblations of the chapel being valued in the king's books at the princely sum of £6, 13 shillings and 4 pence. So clearly this is an interesting feature. It may be adjacent to the present day Inglestowe Hall. Most of the diffuse seepages in salt marsh ecology have been overprinted by 20th century agricultural improvement. An area around Tixall has recently been inspected. The groundwater within the land drainage system was confirmed as being slightly saline. It also had a significant component of iron salts. The remaining area of salt marsh at pasture fields appears to be supplied from boreholes. It is a very sensitive SSSI, as it is a fragment of a formerly extensive ecosystem. I want to talk about the Essex Bridge borehole. This was sunk in the Shugborough estate in 1963 into the Sherwood Sandstone on the southwest edge of the Needwood Basin. It encountered saline water. However, there was scepticism about the result. See the comment on the analysis. Somebody said, I doubt it, against 12,100 chloride. However, subsequently saline water in the Sherwood Sandstone in this area was confirmed by geophysics to date. The presence of saline water in the Sherwood Sandstone in the area east of Stafford is also suggested by the name of the village of Salt. See the plan. This location is underlain by Sherwood Sandstone strata. The source of the saline water intrusion into the Sherwood Sandstone is uncertain. It may be coming from the Stafford halite member in the Mercia Mudstone via an indirect pathway. The possibility of exploiting the coal at depth beneath this area as an extension of the Cannock Chase coalfield was considered in the 1970s, and numerous exploratory boreholes were sunk. At the time, one of the reasons for not pursuing this prospect was due to a high chloride content in the coal. There are several loose ends regarding salite groundwater in this area, like the seepage at Tixall and possibly even the St Erasmus well. Boreholes have been sunk to investigate the Needwood Basin Stafford halite member. There were a few surprises. No halite was present. However, a distinctive brecciated fabric was noted. This brecciated fabric had already been described from the Shoreditch borehole and had also been noted in boreholes sunk in the Stafford and Cheshire Basin, so perhaps it should not have been a surprise. In places, the breccia was re-cemented by gypsum and possibly dolomite, and notably, the gypsum was coarsely crystalline in places. We'll move on, having talked about gypsum, to look about gypsum in the Mercia Mudstone in a bit more detail. So sulfate, gypsum and anhydrite and carbonate, calcite and dolomite are important minor constituents of Mercia Mudstone, often in the porosity as a cementing agent. It is observed that gypsum often occurs in fibrous veins 1 to 10 millimeters wide, commonly comprising 1 to 5% of the rock mass. It is generally acknowledged that gypsum has converted from anhydrite in the presence of water in near surface conditions. The fibrous crystal structure reflecting crystallization within an overburdened stress field as the anhydrite gypsum conversion results in an increase in volume. Near the surface, gypsum is removed by groundwater dissolution. This leads on to the observation of the solution front. Observations from various projects across the West Midlands indicate that groundwater dissolution often forms a gypsum dissolution front, typically to depth of 20 to 30 metres, but shallower beneath the valley bottoms of the Tame and Trent, possibly due to late Pleistocene river erosion. The solution front is often, but not always, abrupt, and the quality of the recovered core across it often improves abruptly. Strata where the gypsum has been removed by a solution is usually rubbly with very closely spaced continuities, sometimes with clay fill, and often disturbed by the drilling process. Core loss occurs and RQD is poor. Just above the solution front, there is sometimes a zone of higher permeability. Below the solution front, where gypsum is visually present, the recovered core is usually clean, with little or no core loss and good RQD. The solution front phenomenon is curiously underreported. Neither the BGS nor Syria mention it. This may be due to the depth that the front occurs, about 20 to 30 metres, and many of the ground investigation boreholes in the past may not have been deep enough to intersect it. Also, recent GI has observed gypsum in a variety of habits. You have the coarsely crystalline version, which I mentioned earlier, the fibrous version, which I've also mentioned earlier, but also you observe a powdery or finely crystalline version. And then say in the Stafford Basin, all three habits are observed to occur together in a few places. These notes about the occurrence of the coarsely crystalline gypsum. These are a few thoughts. Recent GI boreholes has indicated that coarsely crystalline gypsum occurs within the Stafford halite member in the Stafford and Needwood basins, particularly in zones where the halite appears to have been removed soon after deposition. The source of the coarsely crystalline gypsum is currently unknown, but it does not look like it has come from anhydrite hydration. Likewise, the date of the gypsum mineralization is unknown. It may reflect a period in the geological past when sulfate-rich groundwater was circulating below a paleo land surface, a subject for future consideration. Coarsely crystalline gypsum has also been observed in recent GI boreholes in the Cheshire Basin Mercia Mudstone. Here, it appears to occur in the upper part of the Wilkesley halite member, where halite appears to be removed soon after deposition. And then there was the powdery gypsum. Powdery gypsum has been observed to occur within the Mercia Mudstone weathering profile, sometimes at shallow depth and in notable quantities, particularly in the Stafford Basin, but it is observed elsewhere. Its occurrence applies as in places gypsum is being solutioned at the base of the weathering profile on the solution front and is being redeposited within the weathering profile, and this appears to be a very recent and possibly ongoing process. I'm now going to move on to talk about the Tutbury gypsum. Towards the top of the Mercia Mudstone group, in the Branscombe Mudstone Formation in the Needwood Basin, a significant gypsum deposit is present. The Tutbury gypsum forms a strata of almost pure gypsum, about 3, perhaps even 5 meters thick, which has been mined for many years of plasterboard and cement. The gypsum is different in character from the more disseminated gypsum seen in the Mercia Mudstone and recent GI boreholes. Large inclusions of anhydrite are present, and some of the gypsum is very finely crystalline, alabaster. The gypsum is typically in small granular crystals, giving a sugary texture. I now want to talk about the Northwich gypsum mine. As well as a major area of mining fold, the Tutbury gypsum was worked underground between 1930 and 1956, just east of Stowe, which is northeast of Hixton, not far, it's the northeast of the Trent Valley. Exploratory boreholes to the mine indicated that Tutbury gypsum had been significantly affected by solution processes, and other boreholes on the southwest side of the Needwood Basin have also shown extensive solutioning on the horizon of the Tutbury gypsum. And therefore, many of the karst features reported in the area are likely to be due to the solution of the Tutbury gypsum and not the Stafford halite member 16 meters below, although a connection cannot entirely be ruled out. The main feature that needs to be reassessed is Chartley Moss, which is adjacent to the gypsum mine. It is considered unlikely that this is due to salt solution as reported in the literature. Exploratory boreholes nearest to Chartley Moss showed that the Tutbury gypsum is about 5 meters thick at a depth of just 15 meters, and the adjacent Chartley Moss is reported to be up to 12 meters deep. Therefore, the extensive solutioning of the Tutbury gypsum at shallow depth noted in the adjacent mine exploratory boreholes is likely to be responsible for Chartley Moss and its recorded collapses, making a scenario similar to Ripon. Finally, we'll talk about the Tutbury gypsum is currently worked by the Fold gypsum mine. Very extensive workings extend beneath the centre of the Needwood Basin to the west of Burton-on-Trent. And these are a few images of these mine workings from a visit a few years ago, which is a few years ago. So this is a visiting party inspecting the mine workings. The excavation of the gypsum which had been broken up by blasting. The mine is worked by partial extraction with large supporting pillars. The gypsum, apart from the alabaster and anhydrite masses, had quite a distinct bedded up aspect, and samples collected had a granular character, making it different from the gypsum seen elsewhere in the Mercia mudstone. So, to conclude, the brecciation, often observed above and associated with the halite beds, is indicated to be pencontemporaneous, as noted by the Geological Survey in the Macclesfield memoir, and is not necessarily related to the present erosion cycle. Classic wet rock head probably occurs in places, but is not the only process to generate brine. There is a suggestion that many of the historical occurrences of brine is related to the location where glacial erosion has incised into the halite deposits in Cheshire and Staffordshire. We are entering a new period of Mercia mudstone research as more data becomes available. There is certainly scope for a PhD project to consider traditional ideas on wet rock head and the suggestion that other processes are involved, such as the impact of glacial erosion and pencontemporaneous solution and brecciation. And finally, in the Needwood Basin, the Tutbury gypsum, and not the Stafford halite member, is likely to be responsible for many of the karstic features observed. And that concludes the presentation on Mercia mudstone, salt and gypsum, and I'll be quite happy to take some questions.
Right, well, that was really interesting, Adrian. Thank you very much for your talk. Now, if anybody would like to, you can all turn your mics on, and if you'd just like to raise your hand or just type your name in the chat box, then you can ask your question. So I don't see anybody asking questions just yet. So do we have any people wishing to raise a question? Okay. Wow. Silence, Adrian.
Yeah, well, clearly that some of the implications of the presentation do need to be digested. And there is certainly the strong suggestion that some sort of PhD project is required to take on board the new information. And I think the Cheshire Brine Compensation Board certainly needs to be aware of this, because the suggestion being that the currents of brine is more complex than you find in the established literature. Somebody's raised their hand.
There you go. Okay, Kay, ask your question.
Okay, this is an area that I'm completely unfamiliar with, if you like, but I am totally intrigued by the breccia that you talk about. Am I right in thinking that the source of that breccia is relatively recent and due to the glaciation?
No, it's a Triassic age.
Okay,
the geologists who logged the Shirleywood borehole, and many of the geologists who logged the boreholes in the Stafford Basin, has referred to this brecciation as being a Triassic age.
So,
and the observation from Northwich confirms that observation.
And has anyone suggested the paleo environment that explains the presence of breccia alongside the halite?
The Macclesfield memoir does offer some suggestions, that in marginal areas of deposition, where halite has been deposited in the axis of the deposition in the Cheshire Basin and elsewhere, in marginal areas, you do get this brecciation occur. So it is clearly an area that needs more research.